All right, so next problem. And the question I had was, have you ever wondered how tall the Space Needle is? So we can use indirect measures, so setting up proportions of things that we do know when we have one thing we don't know. So like if I know the shadow of the Space Needle, if I know my shadow, same time of day, and I know my height, I could actually solve a proportion to figure out how tall the Space Needle is. And a really common math problem that you're going to see time and time again are these tree and shadow problems. So when we're solving a proportion, we know it's always going to be a ratio equally a ratio, and I'm always going to be comparing two items or two objects. So a 5 foot tall person, I'm going to draw my person, I'm going to label 5 feet, cast a shadow that is 4 feet long. So we'll make it a little bit smaller. There's 4 feet. A tree next to them, okay, so taller, is going to cast a shadow that is 10 feet long. The triangle that these figures make with their shadow are similar. So the shadow with the object is always going to make a 90-degree angle. So really, really important that you draw your diagrams. Okay, so the two things I'm comparing are the tree and the person. It doesn't matter who I choose to put top or bottom at this moment. We're going to fill in what we know. So the tree, we don't know the height. Okay, so the height of the tree, okay, to the height of the person is equal to the shadow of the tree equaling to the shadow of the person. Okay, and so I'm going to look at it. If my variable ends up on the top, cool, let's keep going. If it ended up on the bottom, we're going to flip them just like we did in the last problem. So let's take this out. So the height of the tree over 5 equals 10 over 4. So because I want t by itself, I'm going to multiply since this is division. So multiplying to get rid of that 5. Whatever I do to one side, I must do to the other. So now I'm just multiplying these two fractions. I'm going to put this over 1 just so you can see it a little bit better. 4 and 10, those can both be divided by 2. So I'm going to make that a little bit easier for myself. And then I have 5 times 5 divided by 2, so 25 over 2. 2 goes into 25, so the height of the tree equals, so 2 goes into 25, that's 24, so that's 12 and a half. And I want to make sure that I put on my units, that's feet. So again, let's make sure that this makes sense in my problem. Would it make sense that the tree is 12 and a half feet if the person is 5 feet and casts a 4 feet shadow, and the tree is 12 and a half feet and cast a 10 feet shadow? Yeah, it should make sense that the tree is taller than the person. So just make sure when you do these problems that it makes sense at the end. All right, so the next problem we talked about, I can use scale factor to figure out map distances, or I may just want to figure out what is the scale factor. So I was looking at how far away it is from Pike Place to the Space Needle. And when I add up all of these distances, so I have 1.1, 1.1, and 1, the total distance is 3.2 miles. Okay, and I want to figure out what is the scale. So what is the map to the actual? So we know the actual is 3.2 miles. And then in terms of finding the map, I'm going to physically take my, where did I put my ruler? Here it is. I'm going to physically take my ruler and I'm going to measure each of those three distances. So I have 0.75. I have 3.25. That makes it easy. 4. And then I have another 2. So I got 6.5 total. And I have that extra little piece. So 6.5 inches to 3.2 miles. And I could leave it as that. Or if I really wanted to figure that out, I could do it as a unit ratio. And I would say, I want to know how many miles is it for every 1 inch. So essentially what I'm doing, I'm going to divide this by 6.5 to get 1 inch. So I'm also going to be dividing this by 6.5 to figure out how many miles per inch. And I'm not going to do that right now, but if you want to take a calculator, you can.